Good day everyone, I am going to perform my performance task in statistics and probability, wherein I am going to share my knowledge of solving the population of the sample means. First of all, before we start to solve, we need first to get the weight kilograms of each member of the group, wherein can be used in the formula to compute the mean and the variance of the population. So here is the table wherein has a two column. The first column is the member of the group, and the second column is the weight and kilograms of each member of the group. The weight and kilogram of my mother has 58 kg. My older sister has 55 kg. My little brother has 46 kg. And my tita has 57 kg. So here are the steps. Number 1, compute the mean of the population. Number 2, compute the variance of the population. Number 3, determine the number of possible samples of size. Number 4, list all possible samples and their corresponding means. Number 5, construct the sampling distribution of the sample means. Number 6, compute the mean of the sampling distribution of the sample means. Number 7, compute the variance of the sampling distribution of the sample means. And number 8, construct the histogram for the sampling distribution of the sample means. To compute the mean of the population, we need to use this formula to solve the problem. First, add the weight kilogram of each member of the group. 58 plus 55 plus 46 plus 57 is equal to 216. And then divide 216 by 4 is equal to 54. So the mean of the population is 54. To compute the variance of the population, we need first to subtract the mean of the population from the weight kilogram of each member. 58 minus 54 is equal to 4. 55 minus 54 is equal to 1. 46 minus 54 is equal to negative 8. 57 minus 54 is equal to 3. In the second column, we need to square all of these numbers. 4 square is 16. 1 square is 1. Negative 8 square is 64. 3 square is 9. We need to add all of this. 16 plus 1 plus 64 plus 9 is equal to 90. And the last one is to divide the result into the number of the elements. 90 divided by 4 is equal to 22. So the variance of the population is 22. To determine the number of possible samples of size n equals 2, we need to identify first the given. The number of elements is 4 and the sample size is 2. Here is the solution. We need to use this formula to substitute this. 4 factorials over all 2 factorials times the quantity of 4 minus 2 factorials is equal to 6. So there are 6 possible samples of size 2 that can be drawn. Here is the list of the possible samples and corresponding. To get the means, we need to add this 2, then divide by 2. 58 plus 55 is equals to 113, and divide by 2 equals to 56.5. 58 plus 46 is equal to 104, divided by 2 is equal to 52. 58 plus 57 is equal to 115, and divided by 2 is equal to 57.5. 55 plus 46 is equal to 101, divided by 2 is equal to 50.5. 55 plus 57 is equal to 112, and divided by 2 equal 56. 46 plus 57 is equal to 103, divided by 2 equal 51.5. Here are the 3 columns for sampling distribution of sample means. The first column is sampling mean. The second column is the frequency. The third column is the probability. Since all of these are 1, all of the frequency are 1, and the probability is also the same. To compute the sampling distribution of the sample means, we need to multiply the sample mean and probability. 56.5 times 1 over 6 is equal to 9.416. 52 times 1 over 6 is equal to 8.66. 57.5 times 1 over 6 is equal to 9.583. 50.5 times 1 over 6 is equal to 8.416. 56 times 1 over 6 is equal to 9.33. 51.5 times 1 over 6 is equal to 8.583. And then, after multiplying the sample mean and the probability, we need to add this to get the sampling distribution of the means. 9.416 plus 8.66 plus 9.583 plus 8.416 plus 9.33 plus 8.583 is equal to 53.98. So the mean of the sampling distribution of the means is 53.98. Before we start to compute the variance of the sampling distribution, we need first to put here the sample mean and probability in the first and second columns. To solve the third column, we need to subtract the mean and the sample mean. 56.5 minus 54 is equal to 2.5. 52 minus 54 is equal to negative 2. 57.5 minus 54 is equal to 3.5. 50.5 minus 54 is equal to negative 3.5. 56 minus 54 is equal to 2. 51.5 minus 54 is equal to negative 2.5. To solve the fourth column, we need to square each value of the third column. 2.5 squared will give you 6.25. Negative 2 squared will give you 4. 3.5 squared will give you 12.25. Negative 3.5 will give you 12.25. 2 squared will give you 4. Negative 2.5 will give you 6.25. To get the 50th column, we need to multiply the second and the fourth columns. 1 over 6 times 6.25 is equal to 9.41. 1 over 6 times 4 is equal to 0.66. 1 over 6 times 12.25 is equal to 2.41. 1 over 6 times 12.25 equals to 2.41. 1 over 6 times 4 is equal to 0.66. 1 over 6 times 6.25 is equal to 1.41. After solving each column, we need to add all of this. 1.41 plus 0.66 plus 2.41 plus 2.41 plus 0.66 plus 1.41 is equal to 7.484. So the variance of the sampling distribution is 7.484. Step 8 is to construct the histogram. This side is the probability and this side is the sample mean. The probability of 56.5 is 1/6. The probability of 52 is 1/6. The probability of 57.5 is 1/6. The probability of 50.5 is 1/6. The probability of 56 is 1/6. And the probability of 51.5 is 1/6.